Welcome back to the subject Object-Oriented Analysis and Design. And today's topics are Introduction to the Logical Architecture, Example, one of the architecture that we are going to discuss, Computer Logical Architecture, and the second example is Logical Architecture in Developing the Software, and the fourth topic is Components of Logical Architecture. So today we are going to discuss what exactly and logical architecture, when we need to develop, design this logical architecture. So we'll come across one by one with example. So exactly what is this logical architecture? The logical architecture is constructed, is a type of structural design. So as we know that the designs are divided into behavioral and structural designs. This logical architecture diagram will comes under the structural designs, that is used to provide the detailed description of the system without defining the system technologies or environment. So in this logical architecture, it is briefly defining about the internal hardware, the internal resources that are useful to develop any project or to develop any software. So under this logical architecture, whatever the tiles are required, there is any project or a problem statement can be defined in terms of layered architecture, that is a tiles. It is divided into the tiles. Any project will be a standalone project is considered as an one-tier architecture. If a project requires the backend database and it requires some front-end softwares, then we can say it is a two-tier architecture. So it again depends upon the complexity of an project. So the project can be defined in terms of one-tier architecture, two-tier, three-tier, and it becomes n-tier architecture, depends upon the complexity of an project. So here we are going to discuss what are the tiers, that how we can define any based on any particular logical architecture. So it includes all the information related to the logically and detailed description without using the technical terms in it. So here we are not going to define any technical terms, exactly what are the resources that are needed and how the resources are integrated. For example, if you are going to develop any software, what is the configuration needed for a particular project? We need to look into the machine or a device, what is the internal configuration of that, and the connectivity among these. For example, if the analyst or a developer wants to develop a game application or any animated application, so before going to start doing the analysis of a application, they need to briefly look into the logical architecture of the machine, like what is the configuration, whether the configuration is supporting to develop that applications or not. So under this logical architecture, the analyst will look into the hardware architecture and whether these hardware resources are useful in developing or it is enough to develop any software or not. So for particular gaming application, they need an NVIDIA processor, they need an high configuration memory rather than Intel or rather than a limited memory. So before going to start developing any application, the analyst need to understand the configuration and requirement of the machine, which can be developed with the help of a logical architecture. So coming to the next one, it means it can be considered a diagram used to define the relation between the software components, and at the same time it needs to perform the relation among the software which is going to be developed. So what are the version of that particular software, whether they are going to enhance the version of the software or it is a recycling of a legacy software, or what kind of project that the analyst is going to develop. Depend upon that, it should be related to the whatever the internal resources or the configuration. So that diagram will represent whether it is related or it is reflecting to develop that particular software or not. So the main purpose of designing this logical architecture is to plan for the system and use it for communication before designing and implementing the system. So the main purpose of this is to communicate among the designers and implementing the system. Like it is helpful to communicate between the designer who is going to design and do the analysis and the developer who is going to develop the code. So code developing is totally differ from the hardware configuration. So they need to communicate and then they can fix a logical architecture. Based on that, the code developer will start developing the system. So and by this diagram the user can get the overview of the system. So just by seeing one logical architecture, the analyst or the developer should come to know what exactly the problem or a software that they are going to develop. So let us just understand one of the example, that is a computer logical architecture. For example, if you want to develop any web application, in case of an web application, we require an internet. So internet is a major requirement. At the same time, the scripting languages. So all the scripting languages which is going to be execute. So for executing that, we need one interface. At the same time, we require an internet. So these two software applications are enough to develop any web application. At the same time, when we look into that machine which is going to support for developing this web application, whether this application is going to be developed in the computer, or it is going to be developed in a tab, or it is going to be developed in a mobile. So which device we are preferring to develop this web application? That makes sense, that the relation between the component and the web application which we are going to develop. So here we need to focus that whatever the machine, if you consider that we are going to use a computer to develop this web application, what is the internal configuration of this machine? Whether this configuration is enough to develop this particular software or not. So that makes that analyst has to do the logical architecture for this. So here is one of the simple example computer machine. So if you take any computer machine, so any computer machine will consisting of, if you think that this is an input devices and these are then output devices, will have a main memory, and then we'll have the processor. So here we are taking a simple example to develop any web application. To develop any web application, so initially the analyst was fixed with a system or a machine, a computers. So if you take a computer, here the requirements are, one is an input devices, another one is an output devices. At the same time, we require the memory, and then we'll require the processors. And these processors depends upon the configuration of the machine. It may be a multi-processor. And inside that, we'll have an n number of registers to perform any logical operations. So we'll have an ALU, memory unit, control unit, accumulator register, and then we'll have the program counter. All these are the registers. At the same time, we will have R0 to Rn-1 registers. So exact internal, the processor having some registers which are also the which will hold the data in terms of bits and bytes. And when we talk about the memory, in the memory again we'll have an RAM and ROM, which is a combination of RAM and ROM. And between these two again we'll have a cache memory. To make the machine faster, we are using a cache memory. So when we look into this architecture diagram, here it can be divided into some tiers. So these tiers are, the first tier will represent the input and output devices. So here the first tier is the input and output devices. And when we talk about the second tier, where it is focusing on memories. So here if I take the second tier, it is totally talking about the memories. And when I talk about the third tier, it talks about the n number of processors. Depend upon the configuration, you may have more than one processor, up to 6, 12, 20 or whatever the configuration of the machine. So this is totally focusing on the number of processors. So a simple computer logical architecture diagram to develop any web application, whatever the example that we had chosen, we are totally dividing into three tiers. So the first tier is totally focusing on only the input and output devices. So the second tier is totally focusing on the memories. So under the memories we are having, one is the main memory, the other one is a cache memory. So when we talk about the third tier, it is talking about exactly the processors. So how many number of processors are needed to develop this particular web application. If you take the same example for any gaming development, any game application, or to develop any animated application, we need to focus the first tier as an input output devices. When we come to the memories, we require the high configuration of the memories. When we talk about the processor, no matter when there is having more than one processor, but exclusively that should be supporting for an NVIDIA applications. So the type of processor makes differ when we are going to differentiating in developing the softwares. So according to that, the analyst first has to design a logical architecture. So based on this logical architecture only, the next analyst who is going to develop the code can have a brief idea where to start and how to start that particular coding. So this is nothing but a logical architecture diagram, a simple example. So if you take this particular example to develop any software, here we required one is an users. So user are considered as a client tier, whereas the second tier is an access tier, the third one is a presentation tier, the fourth one is a business service tier, and the last one is a data tier. So in the previous example, as we know the internal configuration of the machine, we are able to differentiate into number of tiers. So whenever we are going to develop any software, the analyst should be very clear in differentiating these tiers. Based on what application that the analyst or a developer is going to develop, they should be very clear with all these tiers. Based on these tiers, what are the services that each and every tier is going to be provide, and how the connectivities are done, what is the internal connectivity from tier 1 to the tier 2, tier 2 to the tier 3. So whenever we are going to say the complexity of the project, it depends upon n number of tiers. So for all these tiers, how it is going to be internally connected. So here you can see that each and every service is interconnected with every tier. So based on that, the user is going to directly interact with the machine and they are going to start developing the project, and the other client who is a Java client is going to be check the whatever the resources and the status of this particular work. So as we know that a team members can be developing the project. So there may be a different type of client who is going to be interacting with the system and they'll start developing the work. So based on that, they should be having an awareness on how internally they are connected from one tier to the another tier. This is a general updated software application logical architecture, but according to our syllabus in our prescribed, it's an old version of logical architecture, but better it can understand these kind of architectures to develop any softwares. So whatever the logical architecture diagram just now we had gone through, so there is one common tier architecture is defined that contains 3 tiers that are used to define the response request cycle. So if you see in the last, there are some of the tiers who are interconnected with more than one tiers. So if you take simply this presentation tier, which is connected to the access tier, which is connected to the business tier, which is also connected to the data tier. So the first analyst should understand what are the connectivities from one tier to the another tier. For example, we are developing a database project. For this database project, how we are going to connect the backup data towards the front-end web application, how the data is dumped towards the web application. Here we will get one tier, like what are the connectivities that we are using, what are the interfaces that we are using to connect. So coming to that, the user uses the presentation tier to generate the request. The request is immediately transferred to the application tier. So here it is going to briefly define what exactly the external architecture that we have discussed. In the application tier, further process is done and the data is fetched from the data tier that is required to the in manipulation. So here we have to briefly define each and every tier, how they are communicating and how the services are provided for each and every tier. I hope you understood the logical architecture with an example. Thank you.